Today's lesson will explore true lengths. But before we get into the true lengths, I just want to review something that we would have looked at in the introduction to orthographic projection. You should recall that we looked at a line and projecting views of a line through the principal planes of projection, that is the vertical and horizontal plane. So you should remember this representation that is on screen right now. You should also remember that we took that line and we moved it through a different angle to allow us to see what that line would look like when we projected it. So we had changed the orientation of the line where we didn't have a dot in the plan anymore, but we actually had a shorter line, and we had a shorter line in the end view, meaning that the only view that showed us the actual length of the line was in the front view. I think I would have mentioned to you then that the topic of true lengths would allow us to look at lines in different positions where those lines did not appear either in the vertical or horizontal plane, and that means that we would have to do a special construction to determine what the real length of the line would be. So I'm just showing you what we would have looked at previously. You should remember that we had looked at the planes of projection, and we had placed objects in those planes to allow us to understand what first angle and third angle projection representations were. And you should also remember that we had placed the XY line, which we refer to as that hinge line, to allow us to transfer measurements if we needed to, or make references if we needed to. Then the XY line provided that opportunity. So let's get right into the true lengths then. This page shows you 3 constructions, and each construction is a different method for determining the true length of a line. What you will basically have is 2 views of a line represented, and then you'll be required to use those 2 views to produce the true length of the line. So for you, in this situation, we will take off some of the lines as is our norm. So please just give me an opportunity to take off those lines. And once we have taken off those lines, we'll be in a better position to actually see what it is that is required of you. Just one more line to take out. So what we have here on this drawing now is front view and plan of a line. This is orthographic projection, therefore you should be able to see that the 2 ends of the lines actually line up. If a vertical line were pulled, then you will see the ends of these lines lining up. But the lines are at different angles because the line, remember what we did with the pencil, does not fall in the vertical or horizontal plane. So we also have in place our XY line, this green line represented here, and we are able to reference these if need be with regards to any construction. Now, in order to get the true length, remember we said that you had to be looking at 90 degrees to an object in order to determine the true length. So for us then, we would have to take one of these lines and swing them through 90 degrees to bring them to a horizontal position. In this instance, we're using the front view. So what we will do with the front view is that we will put compass point at the end of the line here and open so that we're able to swing this curve around to horizontal. Now, horizontal in this instance then would look like this, where you pull a line across to meet that curve, and on the plan for the corresponding corner, you will do the same thing, just pull a horizontal line across. The next stage in your construction will be to take a vertical line from the intersection here with your horizontal and arc down onto the plan. So if we dropping that line now, then the construction looks like this, with this vertical line coming in. And the true line for you is actually a line from this point going all the way down to the intersection here. You would then be able to measure that line and state that as the true length that you're required to produce. In this instance, it's represented as a blue line initially, but then you see the true length now being highlighted with this green line. What I will do is highlight all of the true lengths as green lines. However, please understand that when you draw, the true length is an outline, so it will be represented as a blue line in this instance, as the outlines are. But just for clarity, in this case, I've represented the true length with a green line. So this is construction 1, and this method is called the revolution method. We will now move on to example number 2. Example number 2 is called the triangulation method, and it just uses the construction of a right angle triangle to assist you with determining the true length. But we know the drill, so we will take off some of these lines to allow us the opportunity to see what we're doing just a little bit better. So once I've removed these lines, then we should be able to explore the construction. So same as example number 1, you have your two lines, front view and plan, and you have your XY line in position. The first thing you will do on this example is to get horizontal lines from the ends of the line. Remember, this can be done either in the front view or the plan. I'm using the front view in this instance. So these lines represent projection lines coming horizontally from the ends of your lines. Once you have done that, then your next job will be to drop in a vertical line. So this will be one of the lines in that triangle that you're expected to form. The next stage for you will be to take the length of the line represented in your plan and transfer that length onto the horizontal across here. So I've got the arc for that already. So then all that you will need to do in this instance is drop that line in position as I've represented here. So this length is equal to the length in the plan. The true length then is a line connecting this point right here and this point of intersection here. This line would be the hypotenuse of a right angle triangle, and that would represent the true length of the line as represented here. Now, this is a right angle triangle. This method is called triangulation. So you know two methods now, the revolution method and the triangulation method. The third method that we are concerned with is called the auxiliary method. And for the auxiliary method, what you will basically be doing is producing an extra view, similar to what you would have done when you were finding the true shape. You will be producing an extra view of the line by the same methodology that you would have used to get a true shape. So as per usual, let me take off a few lines so that we are able to move a little bit better. Okay, so now we have what we need to see. The two lines in position, front view and plan. And yes, I've deliberately left out the XY line. I will drop that back in fairly soon. The XY line will also be used in the transfer of the measurements for this one. So that is why I left it out initially, so that you can just see what we're doing when we're doing it. The first thing we will do in this instance is project lines from your plan at 90 degrees to the line represented in your plan. So in this instance, I will pull these lines at 90 degrees to the plan view. Now, I will now show you the XY lines in position, because this would have been your original XY line. So once you've pulled those 90-degree lines, you also now want to put in another XY line. This XY line will be parallel to the line that is represented in your plan. Remember what you would have done on true shapes. Then you want to take the opportunity to transfer heights. So you want to transfer the height from the XY line to the nearest point in your front view. Once you drop in that line, then your construction starts to look like this. So that line there is equal to this height here. Then you want to take the height from the other end of the line to the XY line, and you want to mark that as well. So you can now put in that line as well, and the construction now starts to look like this. Your true length then will be equal to this line coming inside here. From this point to this point would represent your true length. So if I drop that in for you now, then this is what your true length looks like. This method is referred to as the auxiliary method. So there are three ways in which you can find the true length on a drawing. No way is right or wrong. What you will do is maybe develop a preference for using a particular method, or depending on what the drawing represents, it may be easier to use one method over another, but you wouldn't be penalized for using a particular method at any point in time. So just remember that, and don't be afraid to use a particular method. However, we all have our preferences, and we may just determine that one method is a little easier than the other. One thing I want to stress to you, because sometimes you will see this on a question, sometimes you are asked to determine the angle of inclination between the line and the vertical or horizontal plane. So if you're asked to determine the angle of inclination with the horizontal plane, then you would have had to find the true length in the front view here, and then measure the angle formed. If you are asked to determine the angle of inclination with the vertical plane, then that would be a measurement giving you horizontal and the angle formed in there, and that would be the angle of inclination in the vertical plane. So just bear that in mind, because every once in a while you are asked a question about the true angle of inclination for the line that you have found. Now, we will look at an example, just a construction that shows you how you can plot the true length of a shape and then give the actual representation of that shape. So for this example, we'll be using something called a lamina. A lamina is basically a thin piece of material, and that thin piece of material is suspended between the principal planes of projection. So in that regard, then, we end up with a situation where there is no real representation in the vertical or horizontal plane. And with that in mind, we then will have to determine the true length of the sides of the lamina as represented here, and then use that information to produce a shape that is representative of that triangular shaped lamina. So what we will have on our page is two views of the lamina, and then what we will do is isolate each side, and you know that each side is represented in the front view and plan. We will isolate each side and take that opportunity then to plot the true length for that particular side, and then we will move to another side and then to another side. So just bear that in mind as we go through this construction. we will take your first side as this side that I've highlighted here. In your plan, then that will represent this side. And we're going to use the revolution method to plot this true length. So for us, if we look at the revolution method being applied, I've highlighted the lines now in red. You will know that you will put the compass at the lowest corner. You will scribe the arc, come into horizontal. You will drop a line down, and you would have a horizontal intersecting that line from the plan view. So then the true length will be a line from that intersection down to here. I have not put in the true length as yet, and I will take my time in putting in the true lengths. I will put in all the true lengths basically at the same time. So just remember, that's how the true length is found for side number 1. For the second side, the side that I'm highlighting here now, we're going to use the triangulation method. So for this second side, then what you will see is this construction where we have, I'm taking it from the plan in this instance, you pull the horizontal lines across, you take the length then of the side in your front view, you drop that here, and then the true length will be the hypotenuse that you have formed. So now we know 2 methods we would have found the true length for 2 sides. The third side, we will use the auxiliary method, where in this instance I've highlighted again the 2 sides, and you know that you would project the lines at 90 degrees. You know that you will definitely need to have the XY line in position. So I've dropped in the XY lines and the corresponding XY lines so that you can see. And then you know then that you want to take the heights in the front view and bring them down onto the plan, measuring those heights from the XY line. So in this instance, your construction then would show these 2 points, and these 2 points, once connected, would represent the true length of your third side. So if I put in all of the true lengths now, and I show you all of the constructions that you would have been using, then the true length for each side would now be represented by these 3 green lines drawn in position. And since you know these lengths, you can then quite easily construct a triangle given the length of those 3 sides. So that construction would then look like this. So each of these lines represents a true length. So the true shape of the lamina would now look like this. Please note that this is orthographic projection, and as such, you must label your views, you must label your true lengths, you must label your true shape. So marks will be awarded for all of those things. Also then, if you are questioned on true lengths, true shapes in a multiple choice exam, or if you have an exam where you're asked to draw these, then there should be no major problem. Please note that this is an introduction and that a question may be worded in a way where you may be given the true length and asked to come up with the elevation of the line, or vice versa. So you have to be thinking all the time when you see questions related to true length. It is not that the information isn't there, but sometimes you actually have to think it out to determine what is best for you to do to come up with a solution. Thank you for your time, and I will be bringing you another presentation pretty soon.